Assalamualaikum and hi. Today, I'm Sir Hisham. I want to explain to you on Introduction to Data Communication System. Okay, so we got 2.1, 2.2, 2.3, 2.4, 2.5 till 2.6. Start from Data Communication System, Data Communication Networking and Internet (OSI), and TCP/IP protocol, data encoding, decoding, encoding, multiplexing and demultiplexing, data switching principle and reliability. Okay, the rest you can click on YouTube. Okay, basically the term telecommunication means communication at a distance. The word data refer to the information presented in whatever form is agreed upon by the parties creating by and using the data. Okay. Data communication are the exchange of data between two devices via some form of transmission medium, such as wire cable. Okay, now fundamental characteristic. Okay, the effectiveness of data communication system depend on these four fundamental: delivery, accuracy, timelines, jitter. Okay, now the five components of data communication system, you must have message, sender, receiver, medium, protocol. That's what you learn in principle of communication. Okay. Now, direction. This one also cover in principle of communication. Simplex mean one way of data. Okay. Half duplex mean something like last time you learned about the walkie-talkie. Okay. This one like FM radio. Full duplex mean something like you can transfer both data at the same time, for example talking through phone. Okay, now data communication, networking and internet. Okay, the network, the key issues, the network criteria we can give in terms of performance, reliability and also security. Okay, the terminology, the throughput or bandwidth of a channel is the number of bits that can be transferred per second. Okay, the latency or delay of a channel is the time that elapses between sending information and the earliest possible reception of it. Okay, this is terminology. Okay, for network topologies, define the way hosts are connected to the network. Okay, now network topology issues. Last time in previous slide I already explained about the network topology. A goal of any topology is the high throughput and low latency. Okay, now bandwidth. Okay, bandwidth and latency. Okay, you can read by yourself because last time also learn in datacom and principle of com. Okay, categories. Okay, categories of topology. Okay, we got mesh, star, bus and ring. Okay, this is how you connect your computer on network. Mesh, bus, star and ring. Okay, this one hybrid means, for example, this one you using bus. Okay, now what is the internet? Okay, internet means you can connect anything to the network and then you can share information. Okay, now, okay, basically you must know when you deal with the internet, you must have the provider, ISP provider, and then you must have protocol and you must have internet standards. Okay, okay, for service view, you must have infrastructure that provides service to the application, provide programming interface to apps. Okay, basically you already know this thing. Your normal life. When you use your phone, your laptop, you want to send email, okay? Okay, now we go to the OSI and TCP/IP protocol, okay, and standards. Okay, what is the protocol? Okay, okay, for human protocol, what's the time? I have question, introduction, that's human protocol. Okay, network protocol, machines rather than human. All communication activity in internet governed by protocol. Okay, what is the protocol? Protocol define format, okay, order of message to send and receive among network entities. Okay, so this is example. Human protocol means if in order for you you want to talk with someone, you must have information source and then sender. Okay, something like that. And then similar like PC. PC, you send the data and then for example your PC you type something, request data and then TCP will give TCP protocol will give you connection response. Means after you type something, for example, you Google, you type the address, they click search, then you will find the data. Okay. Okay. Protocol layer. Okay, network are complex. You should know something. In order for you to send the data, you integrate a lot of things. For some of you using phone, some of you using computer. Okay, so this is the thing that you must deal. That's why we must have protocol layer, because like lot of hosts, routers, okay, and then protocols, hardware, software. We need protocol so that it organized. Okay, so give like this. Let's say we take examples, something like ticket process in you when you want to take airplane. You want to go somewhere, start from the ticket purchase, baggage check, gates, run off, take off airplane routing, and then airplane routing till baggage claim, gate unload ticket, and so on. We got a series of steps. Okay, but if you have layered it out, it become more smooth. For example, you got a plain routing, and then what happened? All of the from departure to arrival on the airplane routing stage. For runway, we got the layer for runaway. Okay, for ticket purchase, under ticket layer. So each layer implement a service. Okay, so via its own internal layer action, means when you make by layer, it becomes structured. Okay, now while layering, as what I mentioned, okay, dealing with the complex system. So you want to make it organized. Okay. Now, the OSI model. Okay, what is the OSI model? OSI is not a physical model. Okay, but we provide a framework for creating and implementing network standards. Okay, now this is the OSI layer. Actually, we got 7 layers: physical, data link, network, transport, session, presentation, application. Okay, the upper layer, this one we call upper layer. Application provides the interface, presentation present data, session keeps different application data separate. Okay, the lower layers, transport means provide reliable delivery, network provide logical addressing, data link combine packet into bytes and bytes into frame. Okay, provide access media using MAC address. Okay, physical layer move bits between the device. Okay, this is the function of OSI layer. Application file, print message, you can read by yourself. Okay, now TCP/IP. TCP/IP is the Transmission Control Protocol Internet Protocol. Okay, so actually TCP/IP extract from the OSI layer. But in OSI layer we got 7 layer. For Internet layer protocol we got 4 layer. Okay. Now in order for you to send the data, for example, you want to send email from source to destination, maybe you want to send to your friend, we got message. Okay, when we deal with every layer, for example, application to transport, they will put segment HT, and then transport to network, they put data gram. From network to link, they put frame. Okay, so in order for you to send your data from source destination, this is a process we call encapsulation of data. Okay, so from start with the message, ending with message. Okay, now we go to data decoding and encoding system. Okay, this one for the digital signal, this one for analog signal. You already learned before. Okay, now digital signal 0101. Okay, now we go back to the principle of COM. We got analog source. What is the AD? Analog to digital converter. This is source encoder, channel encoder, power amplifier. Okay, so now what is the line encoding? This one, line encoding. What is the line encoding? Okay, what is the function of the line encoding? Okay, line encoding is a process converting binary data into the digital signal. Okay, why we need line encoding? Line encoding, okay, after passcode modulation. So after passcode modulation here, line encoding. Line encoding. Okay, line encoding, the purpose line code is to match the output to the channel. Okay. Now, remember last time we give you the signal 010001, you draw the signal. Okay. Manchester, differential Manchester last time. Okay, now we go to the multiplexing and the multiplexing. Okay, what is the purpose of multiplexing? We combine, means a lot of data can using the one channel. Okay, For example, you got right now you got 30 student in class. Call your father or your mother and so at the same time, no problem. You got multiple phone using one line channel to transmit data. Okay, now multiplexing, so you can read, you already learned in PCOM. Now, where multiplexing, we use in telephone system, telemetry, satellites, okay, modern FM radio, and modern TV broadcasting. Okay, so this is the common type of multiplexing. We recap back: FDM, TDM, CDMA. Okay, now this is how the FDM look like, TDM look like. Okay, so this is frequency multiplexing. Okay, channel 1, channel 2, channel 3, channel 4. This is just an example. Okay. Okay, you can go through this example, or actually I copy from the PCOM slide. Okay, we already learned in PCOM. Okay, now we go, this one also TDM. Okay, TDM, each signal occupy entire bandwidth of the channel. Okay, time. Okay, now, okay, you can see how the data flow. Okay, time. Okay, synchronous TDM and synchronous CDM, you can read. Okay, okay, you can read the process, actually how the data send. Let's say A, what happened? A here, D here, A, and then what? The first frame, nothing, then nothing, got C, A, B, C, D. A, B, C, D, frame 1, and then frame 2, A, B, nothing, D. Okay, something like that. So you can understand you can study by yourself this thing. Similar that synchronous, how the data transfer. Okay, okay. Synchronous, you can see how the data move from frame 1, frame 2, frame 3. Okay, okay, multiplexing and multiplexing. Okay, uh, this one you can read by yourself. Simple how to send the data. For example here, A1 and then C 3 and then D 4. Okay, something like that. You can study by yourself because already learned in PCOM. Okay. Okay. Now data. This one is recap. Data switching principle and reliability. Okay. We got, in order for you to send the data, we got three types. Okay. How you want to send the data. Okay. First, we got the circuit switching, packet switching, and also message switching. Okay, okay. For data transfer, this is the switch network. We got circuit switching, packet switch network, and message switch network. Every techniques got advantage and disadvantage. Okay, so basically how the circuit switching look like. Okay, okay. Packet switching. Okay, packet switching method using the two routing method. The first one, datagram switching. Yeah, this is the data, how we want to transmit between let's say host A to host B. So this is how your datagram packet move. Okay. The second one, virtual. Okay. Okay, virtual packet switching. How you send the packet. Okay, from source to destination. Okay, this is you can read by yourself. Message switching. Okay, this one, message switching means message, store, and then forward. Store and forward. Don't worry, we will recap on the next chapter. This one is just an overview. Okay, so this is the book. So I hope you understand what I explained about. If you don't understand, we will do on tutorial. Thank you.